Hi, good morning, good afternoon, good evening, wherever you are. Thank you very much for joining us, the Densify webinar series today. My name is Andy Welton. I'm the VP of Technical Sales. Special guest star today with me is Brenda Bollinger, our Director of Strategic Partnerships. Brenda, are you there?
Hi, Andy. Nice to have to join you today.
Awesome. Yes, nice to have you. It's always good to mix it up and have different people. Brenda's specialty is working with our partner community, and this particular topic is near and dear to her heart because we get a lot of questions from our partners around the free tools that are provided by the various cloud providers. So we're going to dig in on that content in just a moment, but before we get started, I just want to let you know there is a question and answer window inside the GoToWebinar. So if you've got questions, please post them in there and we'll save time at the end of the presentation to get to them. And if you're on this call and you're looking for a recording, we will provide that and we'll make that available to you, actually everyone who registered for this webinar early next week. So let's get going. So what are the first two questions and what prompted this webinar in a lot of cases are the questions that we receive from sometimes our prospects, our customers, and our partner community. We are an enterprise-grade cloud and container optimization technology, and we present our product and we show our demonstration. And a lot of times we'll hear one of the two questions in various forms. One of them is, hey, the cloud providers, they give us a bunch of free tools. How are you different? Or we have these tools and we don't need you guys. And then the other one is we get optimization recommendations and we can't get folks to actually take the actions, which is a very common issue we hear through the partners and through our customers and prospects. So two big issues that we have to deal with. So, and the first one that I like to address and right off the bat is, why do I need to buy your software? Well, in some cases, you don't. And for some of our prospects and customers, we talk to them, it would be like, akin to killing a fly with a sledgehammer or a shotgun, or use your favorite analogy here, where it's just not necessary, where the size of the cloud spend, or as they're moving to the cloud, it just doesn't justify a full-blown solution like a resource optimization solution. And we're going to talk and differentiate about those things, but maybe the cloud spend is minimal on a monthly basis. Maybe the amount of savings that they would glean from using a full-blown resource optimization solution just wouldn't provide the payback. There may be other reasons as well, depending on the types of services that they're using, but in some cases it's just not appropriate. And so we have those kinds of discussions with prospects and say, you know what, this is too much for you. You don't really need it. And maybe the free tools are good enough. And what kind of free tools are we talking about here? So three that we're going to focus on here today, well, actually more than three, but every one of the three major cloud providers. Azure's got the Azure Optimizer. Google Cloud Platform has got the Compute Engine and provides various types of recommendations. And AWS gives you a number of different choices between the Trusted Advisor, Cost Explorer, and the Compute Optimizer, providing different types of recommendations, right sizing versus some of the security checks and some recommendations around auto scaling groups. So the purpose of this webinar is to get into what some of these tools do well and where some of those tools would actually fall short. Now, what do the tools actually do well? So the very first thing they all provide, and they do a really nice job on, is just the bill slicing, dicing, the visibility, who is spending what in my public cloud and when, is it getting higher, is it getting lower, and the ability to essentially slice and dice that data. And they all do a pretty good job. Would you agree with that, Brenda?
Yeah, more often than not, certainly as they get going, that's more than sufficient for the requirements.
Another thing they do well is just, the high level performance and telemetry checks. So ability to look into, high level monitoring information, CPU processor response time information, system updates. You can see some of the various ones. This is an Azure screenshot here, network monitoring information. So high level, what's happening right now in my cloud. So typically you have a number of different free tools in all those three different clouds that will help you with that. Governance checks and security checks. A lot of cases, even some of the paid cloud, what we call the Cloud X vendors, might even take some of this information through an API and expose it in their actual product. So they'll take information like you've got open ports, or I've got recommended actions around multi-factor authentication on a root account or something, just security exposure. This is a screenshot from Trusted Advisor. Or it might be simply, things like elastic IP addresses. You could say that's a governance check or just a cost check. Reality is, if you leave these things unassociated and leave them basically configured, those things can actually cost you a fair bit of money. In this case, we're just showing, there's a bunch of elastic IP addresses here, and this customer is costing just over $1,000 a month. So, you turn those things off, you can actually save some money, or you can close some security holes. So again, from a high level, cloud tools are going to help you with those things. They're good for it.
And they know their own solutions best, so they're the right ones to provide those checks easily.
Right. Yeah, good point. And then finally, what do the cloud tools do well in terms of identifying and terminating unused resources? So idle instances, we're going to talk about that in a moment, because in some cases they may be terminating those things a little bit too fast, but talk about the instances, load balancers, database instances. So essentially, you're not using them, why don't you switch them off? It's a good idea. Storage side, abandoned or orphan EBS volumes, idle snapshots that are associated with VMs or instances that have been turned off. So these are all good things to do on a regular basis, and those free tools will usually give you some pretty good visibility on them, saying not being used, turn them off. In this case, the impact, $340 a month. So that can actually generate some fairly good savings. And so from a high level, yep, free tools are going to do some good work for you here and help you out. Now, if we go into, where does the vast majority of the problem lie here? So we talk about IaaS, and this is a chart from Gartner. So the number one spend, as you can see across this area, is actually SaaS. So spending money in SaaS, Salesforce, or whatever the services that you are using, paying for software as a service in the cloud. The second biggest one is IaaS. So the infrastructure as a service, and you can see from a growth perspective, 2020 to 2021, growth of over 25%, approaching 28% in 2021, estimated to be around 26% next year. That should say 2022. That's a nice typo, missed that one. But anyhow, it's growing, and it's not getting any smaller. It's the second largest area of impact. And so let's just focus on that, because if you can actually impact savings in this area, then there's some significant savings to be had. Now, who's standing in the way of you actually saving that money and helping out in optimizing the environment? It's really the engineering, the DevOps group, application owners. Biggest challenge, and we had a webinar, I think it was last month, with J.R. Stromont from the FinOps Foundation. And the number one issue was getting engineers to actually take action, or actually take the optimization recommendation that are being generated from whatever tool that you're using, paid tool, free tool, what have you, and getting them to actually do something. Now, why won't they take action? So first off, and we hear this all the time from our prospects and customers, it's trusting in the answers. So I'm not going to turn this thing off if it's going to save me whatever, $30 a month, because if I do that and it puts my application at risk, it's not worth it. So trusting the answers that are coming out of the free tools, and actually the risk associated with that answer being wrong. Comes up with a whole bunch of answers, like you've got 500 or 1,000 answers to actually take care of. It's like just the effort or sheer volume of actioning that information. And sometimes it's like, I don't have enough time in my day job to actually make that happen. Finally, the motivation. I was talking to one insurance company yesterday, and they just said, the engineers don't care about costs. They've got other things to deal with, but the motivation isn't to save money. It's just to keep the lights on and keep the applications working. So they're not interested in that. So you're laughing, Brenda. Obviously, you've heard this one before as well.
Often. But as the problem grows, then it becomes more and more important. So it is a matter of its timing, I think, in a lot of cases. Again, to your analogy earlier with the hammer and the fly, right? Once the problem becomes big enough, all of a sudden now you have to deal with it. And how do you?
And one of the reasons why FinOps has become, these two teams realize that in the past you do see friction between them, but they realize they have to work together. We're going to talk a little bit more about that later on, and finding the motivation to make these things happen. One of the customers I was speaking to recently, and this is their quote was, hey, 2020 was focused on bill visibility, cost allocation between the different business units, and maximizing our RI utilization and savings plan coverage, obviously an AWS customer. But in 2021, our focus is on ensuring application owners are using the right kind of instances for their workloads. So as far as they're concerned, they've solved what they might consider to be the lower hanging fruits. Not to say that it's easy, but they've solved that piece, or at least they think they've solved it. And now the next point is they realize there's a whole bunch of waste or overspend that's happening. And now they want to align the application with the correct supply. So let's take that particular focus and move into looking at the native tools and how they would help you actually make right sizing decisions on your compute, and mainly focus at this point on these infrastructure as a service. So your database services, your EC2, your VMs, your Google Compute engines, those kinds of things, and containers as well. We'll talk about that too. So if I take the first view, and again, we've got what's the feature, we got Densify, and then the 5 different tools I spoke about a few slides ago. How well do we do? So first off, multi-cloud. If that's your requirement, if you've got more than one cloud, and I think I saw a stat the other day that 92% of the companies out there have got a multi-cloud strategy, you're dealing with 2 or more of these tools. So you're not going to get any Azure information out of AWS Cost Explorer, obviously. So if you're going cross-cloud, then you're going to use more than one, and it's possibly fine, depending again on the situation you're dealing with. Observation period is a very important one, and the idea being how much information, how much history do I need before I can action a recommendation? So you'll notice across the line here, I'll come back to Densify in a moment, but the idea is that I've got 14 days of history, and that's what I'm going to base my recommendation on. So all 3 AWS tools, Azure Advisor says 14 days. There's some of their documentation talks about 7 days for idle resources. So just put 14 there. It's not exactly clear. And then Google Compute is, I need 8 days worth of data in order to make a recommendation. Problem with this is, we've got customers with different applications where they might need 31 days, a full-blown month. And some months, 30 days not enough. It might have to be 31. Or it might need a full quarter. I might need 91 days of history in order to make a recommendation. Point is, a lot of times that this is not enough history for you to say, you know what, that thing is idle, or it can be downsized or switched off. 14 days is just not enough. Anything to add there, Brenda?
I think back to your comment of earlier, trust. We are often asked, how many days of data do we need? We don't need a lot of data to make a recommendation. How many days of data do you need as a customer in order to feel confident that you can take that answer and action it without further analysis? And that's really where the configuration comes in, because the answer is not one size fits all.
Right, and we're going to talk about that as well, because you've got different types of workloads, different classes of applications where test dev, maybe 7 days is enough, but this other critical application, I need a quarter's worth of data before I can make a decision. Now let's get into the different kinds of recommendations. I mentioned them a little earlier, things like idle or terminate resources. And I said, for the most part, at least all the cloud tools make recommendations around these things. Again, for Densify, fully configurable and transparent. You're going to get into some, I should describe the nomenclature to the point here. So we've got, from the top point, it's like the rules configurable. Are they somewhat configurable, or are they not configurable at all? So configurable rules basically means they can be adjusted as required. Semi has some flexibility, possibly in a threshold setting, and non-configurable obviously means you can't change it. And the next component would be, what about the recommendation when it comes up? Is it transparent, which means does it get into the science of how it made its recommendation? That would be a transparent one. And ones that don't actually tell you how they come up with a recommendation, we call that a black box. So a decision being made in a black box, you can't see how that recommendation or the decision criteria is just not exposed. So idle or terminated instance, configurable for Densify in terms of how much history you need or the thresholds. For AWS Cost Explorer, Trusted Advisor, and Azure Advisor, those things are non-configurable. So the rules themselves are not configurable. They are transparent in terms of telling you how they actually come up with the answer. And for Google Compute Engine, they're not configurable and they don't tell you exactly how it comes up with those answers.
So an example, for the configurable or non-configurable, they would tell you, for example, they're going to use peak or they're going to use average, and they'll tell you it's 1%. But what if you want 2% to define ADL, or what if you want 0.5%? So the question is, if the rule fits, that's great. But if the rule doesn't meet your requirements, it means that you're going to now need to do investigation to decide if it's something that you can execute. Configurable means you get to adjust it to meet what you define as required.
Right. And let's hold that thought. You just mentioned something about average versus peak versus, percentiles and things. I want to come back to that in just a moment, because it actually is really important in terms of the math and figuring this out,
Sure.
how they expose that information. But it's probably its own table, and we only have, another 15 minutes for this webinar, actually 12, so I better get moving here. Different types of recommendations. So a downsize recommendation essentially means that the instance is over-configured. It's too big, we want to make it smaller. So again, fully configurable and transparent rules in terms of how we actually make those recommendations. For AWS Compute Optimizer, that is non-configurable. It is a black box. It will produce up to 3 recommendations for you in terms of different instances you could size to, but they don't tell you how they come up with that math. Cost Explorer is non-configurable, but it is transparent in terms of how it comes up with its downsize recommendations, and Trusted Advisor doesn't do that. And for Azure Advisor, it is a semi-configurable, so some of the parameters are configurable and they do tell you what's going on. And Google, once again, is non-configurable in terms of how it comes up with a downsize recommendation, and it's a black box. So it's not that criteria is not exposed. Upsize recommendations. This is where an instance might be in trouble or breaching a service threshold that you've defined, and you need to actually make it bigger in order to potentially meet a service level. So again, those are things that are out of the box with Densify, configurable rule sets, all fully transparent. With Compute Optimizer, again, non-configurable, up to 3 different recommendations to make that larger, but they won't tell you how they're coming up with decision criteria. Cost Explorer, Trusted Advisor, Azure Advisor, no recommendations in this area at all. So if you're dealing with risk and trying to actually potentially look for larger instance sizes to better meet that demand, it won't come up with that.
And certainly it'd be kind of dangerous if you would recommend it to get smaller when necessary, but it wouldn't get larger. That would be another area where your customers might have an issue with that. Well, I'm okay to go down, but I need you to tell me when I need to go up as well, because workloads can grow in requirements.
Yeah, change over time for sure. Cross-family recommendations. So this would be a recommendation that would say, hey, you're currently running, say, in a compute optimized instance, and it might the application might be better served to actually run in something like a general purpose or an IO optimized or memory optimized. So again, those recommendations standard from Densify. In fact, I'll show you an example in a moment on that. You will get those kinds of recommendations from Compute Optimizer, again, based on the parameters that are specified here in terms of observation periods, et cetera. Nothing for the next 3 tools, Azure or the other 2 AWS tools, not designed for that. And Google Compute Engine will actually produce cross-family types of recommendations. Effort level to move. This is related to cross-family, which is if I'm going to move instances, it might be somewhat different in terms of what those different hypervisors. So the parameters cross-family might be different hypervisors, support for different network types, different storage. There might be different published IOPS thresholds for the instances. So the idea is, can you tell me how hard it's going to be if we're moving from this instance to another, so that I can potentially automate it, but also see if whether or not that's a lot of effort to actually go through and give an estimate on that side. So again, the effort level is fully configured and fully exposed within Densify, and none of the free tools will give you any information if they're making a cross-family recommendation, what it's going to take to actually do that. What are the differences between the instances? You'd have to look that up.
And in a large environment, it would be important to be able to quickly identify low-hanging fruit, for example.
Right. At this point, I think before I just expose the next one, keeping an eye on time, it's important to note that within all these recommendations, there are are you deciding based on peak? Are you using average utilization? Are you using some sort of balance between them? Sustained activity is what we would call that. What percentile are you using, if you're using anything at all? Like the 95th percentile, you're going to throw out the top 5% of the resources that you're seeing, or the data samples that you're seeing. And again, the idea here is, how are you coming up scientifically with that answer? And average a lot of times can be, if you're basing your answer on average, that can be very risky. If you're basing your recommendation on the peak utilization seen within the period, sometimes it's like that may be too conservative. And then if you've got different types of rule sets that need to be actually used for different types of applications or business units or what have you, the idea that I can set policy different for different types of environments, that can be very important. So all those different mathematical parameters are not reflected in here, but what we often find is that they're, using averages or using peaks is what these tools will typically do. And the answer is usually way too aggressive or way too conservative. There's no in between at all.
And it's fair to say that when we put configurable, you can choose. That is part of the configuration. In this particular rule set, I do want to use average, maybe
Right.
because it is test dev. And yet in another set of rule set, I want to use peak because it's production critical. That is an element of configuration.
Right. So, that idea of multiple rule sets and being able to treat different applications differently, very important for our customers. Free tools are just not going to help you across the board with those things. The ability to leverage additional metrics, something like a Datadog or a Splunk or whatever tool you might be using that's capturing additional metrics. Can you import those metrics? Can you use them as part of your decision criteria? The answer is with Densify, yes, and we see these monitoring tools a lot of time, quite often turned on for things like memory statistics. They're available. So that can be very important for enterprise types of decisions. Free tool is not going to help you there. And then finally, will it produce information around right sizing your containers? This is a huge growing area. It is a webinar all on its own. Some of the tools out there, the free tools, will give you at least some information in terms of cost information or visibility in terms of what's running, but no recommendations around right sizing or optimizing how you've configured those containers in the first place, using the same kinds of parameters you're seeing here. So that is, like I said, it's an own webinar decision. If containers are important to you, then and optimizing containers are important to you, then that's something that something like a Densify is going to help you with, where the free tools will not. Keeping an eye on the time, just a couple more slides. I want to leave some time for questions at the end. Why are answers better than the free tools? Let's just dig into that. What we do in the Densify Analytics is we'll scour through history and say this is 90 days worth of workload history. We will boil that down to a predicted 24-hour window of what this, in this case, an instance in a specific metric, maybe it's CPU or disk IO, whatever it is, it will show a 24-hour predicted model, quartile based on every hour, that says, what are we predicting this thing is going to do in the future based on what it's done in the past. Data is normalized to benchmarks, so we know what kind of chipset it's running on, so we know the relative compute capabilities of that. That will help us as we make recommendations to move across instances or even cloud providers. In this case, we can view through, what is this workload doing on a predicted basis? It's going to peak around 6 o'clock in the morning with some high sustained activity. We call them benchmark units here, but it will show CPU utilization, megahertz, and it's all normalized again to that benchmark. It's going to dip down between the afternoon hours and then go back up again. We'll add into that normalized catalog. So we'll do an analysis of this workload on every single catalog it's available to run on. We'll add in the deep policy that says, you can only run at a certain, peak CPU utilization, a certain amount of memory, maintain the same storage config, consider the existing reserved instances that are running. We didn't go back to that in the last chart, but considering, whether or not you're covered already by a long-term savings vehicle. And we'll come up with an optimization recommendation, which in this case might be move from a general purpose to a more compute optimized to deal with some of these spikes we're seeing here, as an example. And it could be, an AMD recommendation in there, or Graviton, or back to Intel, what have you. So very deep machine learning analysis of that workload pattern to make sure that we're capturing everything. The app owners then. So when they take an answer like this, every single answer comes out of Densify as, not a black box, but a report that tells you, how safe is this going to be? What is the basis of the answer we're coming up with? So a reminder of the policy that we're actually using to analyze, which is maybe I need a quarter's worth of data. I'm going to look at the 99th percentile, all that information. The before and after, so the business cycle utilization on that predicted day and the busiest day down below, and what it's going to look like when we move it to a instance in the same family or a different family. So what's the predicted utilization going to look like? And what is the impact of the cost, whether it's up or down? And then all those details can be used to actually go through an approval cycle. So saying, as the application owner, you're going to be safe. Can you approve this change? Policy and precision and trust. That's how we get these answers automated. So you cannot automate a bad answer. And this we found out from our customers. A lot of times they'll get the answers out of the free tools and they're just not going to action them. So once we have the answers, taking that whole idea of saying, you know what, we can now take 500 answers and we can actually build them into our CI/CD framework. So again, for a separate conversation or a separate webinar, taking the answers coming out of Densify, automating them through the CI/CD framework, whether it be CloudFormation or Terraform or Ansible, and building into that framework so we can actually automate on an ongoing basis. We call it optimization as code. And it can include an approval cycle. Like I just mentioned, taking an artifact like that application owner report, injecting it into a ticket saying, before I actually change anything, someone's going to have to say, yes, I approve it. So whether it's coming through Jira, ServiceNow, or Microsoft Teams, where they're viewing it, wherever they're comfortable doing it, and making this an ongoing basis of optimal answers. And closing this whole FinOps cycle, the idea that FinOps wants to run everything at the right cost, but they can't do it without the application owners saying, yeah, I'm okay with those changes. Everyone wants to keep the lights on at the lowest possible cost. So we take those actions, provide the evidence for the application owners. It becomes trusted because in some cases, we're not just saving money, we're increasing instance sizes in order to make them perform better. So gaining their trust and approval. The changes will get executed through the flow of the CI/CD framework, and then FinOps has an opportunity to purchase the appropriate quantity of long-term vehicles, reserved instances, savings plans, and optimize those things on a long-term basis. So, in summary, cloud-native tools, great for bill visibility, simple cost savings tasks and governance, as we talked about earlier. The right-sizing recommendations, for instances, and where the big impact is, are just simplistic. They're not adjustable to meet the requirements, typically not actionable, and you have a low trust factor with the application owners and the engineers. And if you don't have their trust, you're not going to be able to automate it. Densify is precise, right-size recommendations, ensure that these are actionable recommendations. All the logic, all of the reporting, the information that says what's the basis of this recommendation? What are you going to do to my application when you do this? And then the ability to take all those hundreds of answers and integrate them and action them through a CI/CD pipeline for this continuous optimization. And so I've come to the end here, and I'm going to look at the questions. I see there's a couple coming through. What is this? Does Densify currently plan to support other public clouds like Oracle Cloud, IBM Cloud, etc.? So Oracle Cloud is not currently on our supported list of tools, but is something we consider on the longer term product roadmap. IBM Cloud, we actually support that through typically the bare metal. So a lot of our customers are actually running in the IBM Cloud their VMware infrastructure. So we analyze that the same exact way as we do any kind of on-prem infrastructure for what we call the on-prem VMware optimization. Other clouds are in consideration. I'll just say that right now. There's other ones as well, like in Alibaba. How do we help clients manage usage savings in lower environments, such as with policies, disabling, disassociating VMs? So there's a number of things that Densify provides in terms of reporting around storage volumes, reporting on unused resources, idle resources. In fact, some of the recommendations that we produce are around switching off idle resources. So in a lot of cases, The recommendations that you would see, you know, from the simplistic or at least from a bill reader, the free tools, you'll see those types of recommendations either through our interface or through custom reports in Densify. Any other questions? Can you help me with my long-term savings vehicles like reserved instances? You mentioned them earlier in the webinar. Yes, so absolutely. I didn't get into what I call the cloud cost intelligence component of Densify today, which is around exposing the bill visibility, you know, slicing and dicing of the bill, some of the things I talked about earlier that the free tools do well. We actually do those things as well. The one key area is really helping customers around things like savings plans optimization, figuring out the coverage, what's the optimal amount to commit to on a 1 to 3 year basis, computer EC2, and also on reserved instance, convertible reserved instances, both in the AWS and the Azure side. So certainly if you got more questions about that, hit us up at answers@densify.com. Just brain stopping here. Talked about the trial. Go to our website. If you're interested in the actual trial and you want to try this out for yourself, just click the button. I won't spend all the time on here, but Densify.com, click start your trial, and we'll get a hold of you and walk you through it. Last piece is the webinars. We've got two ones that are coming up. So next week, 1 o'clock, with Red Hat, Chuck Tatham, our Chief Marketing Officer, the 31st at 1 o'clock, we'll be delivering 1 hour webinar on managing and optimizing container infrastructure. So I mentioned about containers earlier, so make sure you tune in for that one. And then another Kubernetes-based one a couple of weeks after that, April the 14th at 11 a.m. Eastern Time, some more live online training on that side. So go and register here, Densify.com, just click on company and events and you'll get there. Did I miss anything? I know one thing, I've gone over my time and I hate doing that, Brenda, but lots of content to cover here today. Anything else to wrap up on from your perspective?
No, I think you covered off the key points today. Thank you.
Awesome. Well, thanks. It's great having you here today. Appreciate your input, Brenda. Thank you, everyone who joined us today. And if you've got questions, certainly reach out to us at Densify.com or send us an email, answers@Densify.com. Thank you again and have a great day and a great weekend. Take care.